Okay, welcome to Programming Rainbow. In this video, we will be continuing on the series of yellow snow in SDL2 and C++. This is the 6th video, so if you want to follow along with this series, you can go to github.com, Programming Rainbow, yellow snow, CPP, SDL2. You can clone that repository, move inside the directory, open it up with whatever editor you would like to use, and I'll show you the code right here. So we're working with what is in the src directory, the source directory. So by default, that is the code from the final video, from video 10. So if you are just starting with this video, you want to grab the code from the video 5, the last video. You want to grab this source code and put it in src, or copy the directory or change the name, however you want to do it. Okay, so again, this is the 6th video. I just want to show you the final product so you can see what it's going to look like. We have a snowman that we can move around left and right, and we are collecting the white flakes, and we are not trying to eat the yellow snow. If we do, there was a collision there, then the game ends and we can still see our score. We can press space to restart, and we can press escape or tell it to close it. Okay. So in this video, we are going to start working on flakes. What we're going to do is we're going to load the images for the yellow flakes. We are going to set up random number generators for them. We are going to put them into a vector, and there's going to be 10 white flakes and 5 yellow flakes, but you can change that as you like. And we will display them on the screen. It's good. The flake will have its own class and all that. So we're going to start right off the bat by talking about random number generators. I'm going to attempt to explain it to the best of my ability, and we are doing it the C++ way, so it's going to be extra complicated. So my target is to use this Mersenne, I'm probably saying this wrong, Mersenne twister engine, specifically the MT1937. That's what I want to use. But what this doesn't really explain it very well. I can initialize it, or I can initialize it with a seed. It doesn't really say it here, but then comes in, how can we do that? Well, we can have another example here. This is on learn CPP. This is showing the initialization of the Mersenne twister engine called MT here for the name of it. And it's using random device. So it's creating an instance of the random device object and then immediately calling the operator on it, which is going to give it a number. So now the question is what is this random device? And then we are also using this uniform distribution to actually use this. So this is all a bit complicated. So to the best of my knowledge, the Mersenne twister engine gives us random numbers. They're pseudo-random numbers, and it's pretty quick and it's pretty good. It's going to be really good for games. It's going to be good enough. It's not crypto, you're not going to use it for any security purposes because they are pseudo-random numbers. But for games and stuff like that, this is going to work really well. But we do need to seed it. So this random device right here, this is going to give us a non-deterministic pseudo-random number. It's supposed to be much higher quality, but I believe it's a lot slower. And even down here, it says this is generally just used to seed. So what we're going to do is we're going to use this random device to seed our Mersenne twister engine. That's going to be our seed. And then we are going to use this uniform distribution right here, uniform distribution. So this is kind of setting it up again. This is showing they have instanced a random device. They are initializing the Mersenne twister engine. They're calling it gen here. And they're using the operator on that random device to get a random number that is seeding the Mersenne twister engine when we initialize it here. And then we are creating this uniform distribution. It's between 1 and 6. I cannot remember off the top of my head if that's inclusive or not. I'll look that up in a second. Yeah, I'll look in my code if this is inclusive or not. But so we have this random device we created. We're using this random device one time to seed our Mersenne twister engine, and then we're going to use this Mersenne twister engine in conjunction with this uniform int distribution. So down here, we're basically saying our uniform int distribution, it's going to be called disturb, I guess is what they're calling it. And it's between 1 and 6. So down here, we're going to use this disturb, and we're going to use this Mersenne twister engine in it to give us a random number. So it's kind of 3 or 4 different steps here. I'm probably not explaining this very well because it is even, it's confusing to me as well. I think I understand it at least enough to use it, but I'm not an expert at this. So you can read about this, but it is a little bit like I had to look on several different pages, but there is the random device has the operator. So you're allowed to initialize it, and then you're allowed to actually use it kind of like a function call or a method call with the parentheses, and it's going to actually return a value and advance the engine state. So you'll see it 2 times here. One time it's being instanced here and then used. Let's see, not in this one. This one, it's actually being instanced right here. It's being initialized, and then immediately that operator is being called on it. So they're just doing that just directly in line just to seed the Mersenne twister engine right here. So I'm going to do that in 2 steps and then set up the uniform int distribution as well. You're going to kind of see it in my code, but it is a little bit confusing to me. So if you have questions, I'll try to explain it, or you can read all you want about it, or ask one of the LLMs, maybe have them explain it 50 times. I've read about this and had this explained to me so many times by now that each time I forget a little bit about what I learned the time before. So this is C++ random number generators, Mersenne twister engine. Like I said, this works really well and is pretty fast. It is not for crypto though. This is just for games. Okay, so I'm going to set that up first, and I'm going to do it in the game class. So we're going to go over here into game. So I really don't need to hold on to the random device, but I'm going to do it anyway. Like you saw it there in all 1 step, but I've done it in 2 steps. So it's going to complain I haven't. I'm going to need to add random to main.h. That should be good enough to get what we need. So I'm going to do the random device. I'm just going to call it RD. And then I'm going to do the Mersenne twister engine. It is MT19937. I'm going to just call it gen. So 19937. So up here, I am going to immediately, I'm going to initialize the random device first and then use it. So the RD right there. And then down here in the gen for the Mersenne twister engine, I am going to, oops, not that one. I'm going to call it right away, call the operator on it, which is going to give me a random number that I'm using to seed this Mersenne twister engine when it's initialized. Right here, I forgot. So this is basically going to set up my random number, at least part of it. We do have the uniform int distribution. Okay, so I also want to set up some other things. Maybe I'm just going to actually put it above this. But I'm going to load an image for white flakes, an image for yellow flakes. I'm going to also just create a rect for both of them. Now you only really need one rect because I just want the width and height of the, whatever the image. But imagine if your game, you actually used a different image for your white flakes and your yellow flakes and they were a slightly different size. I'm just going to leave a rect for each one. So if you do change your game, you're going to have a correct width and height for each one separately. So I'm going to add that down here. I'm going to put it before these. So basically we need two, and these are going to be shared pointers because I don't want to, in the player class, we allowed the player to load its own image, and we just sent in I'll show it to you. When we created the player class, let's look at the class. We have this shared render. So the game is sharing the render with us, but we have our own image. But the flakes, we're going to generate a lot of flakes and they're going to be using the same image. So I'm going to load the images into the game class as shared pointers. And I'm going to then allow each instance of the flake to have the image that it needs to have. And I'm going to just copy in, like not a reference, but an actual just copy, like pass by value, the rectangle. So they all have their own rectangle, but it's going to copy in the value of the width and the height from the rectangle from game. So that's not shared or anything. It's literally just being copied in as a value. So yeah, so I'm going to use shared render, but I'm also going to use a shared image that is being loaded in from game. So back into the game class. So there'll be two shared pointers. And this one is going to be SDL texture. I will just call it, is it white and yellow? Yeah. I'll call it white image, yellow image. And then I'm just going to make two rects. This is just to make it easier for me because I'm just going to populate the width and the height from the texture. And then I'm going to just let that pass that information by value whenever I construct a flake. So white rect. Sorry, it's an SDL rect. So we have those two rects. We're also going to have a vector of flakes. And then these two the random device and the Mersenne twister engine. So I'm just going to create that vector here while I'm here. We might need to add in vector as well. So this one's going to be unique flakes. These flakes are held in the game class. So unique pointer to flake. Now flake doesn't exist yet, so it's going to complain about that. We're just going to ignore it. And I'm just going to call that flakes. So that's okay that it's complaining about that. So let's look at what this flake class is going to look like. So this will stop complaining here. I'm going to make two new files, flake CPP and flake.h. And if Okay, so we want a class, and it's just going to be called Flake. And we are going to be passing some stuff in. So we have a render that needs to be passed in because each flake can draw itself. We have an image that's going to be passed in because that's a shared pointer as well, just like the render. We're going to have a rect that's passed in by value because it's going to have the flake is going to have its own rectangle. That's so it needs to have its own rectangle because the x and the y will will be specific to that flake, but the width and the height will not. So I set the width and the height in game and just copy those values in. The flake needs to know whether it's a white flake or a yellow flake. So I have a Boolean that is white. And then I'm going to pass in by reference the Messina twister engine, the gen. So it can hold on to its own reference to gen so that it can generate its flake randomly where it needs to be. So all of that is kind of going on. So public so we'll have this std shared pointer, which is SDL render. And because of the shadowing of the names, instead of calling it render, I'm going to call it new render. But the member of the class will be called render. But if I call it render and the member is called render, then I get to complain about the shadowing of the names. So I'm just going to say new. So shared pointer to a SDL texture. And this one can just be called image, although I'm going to call it new image for the same reason. And we also have the rectangle. The Boolean. So the flake knows if it's a white flake or a yellow flake. And lastly, a reference to the Messina twister engine. $99.37. Where is that symbol? There we go. And what I'm going to do is I'm not going to define this constructor. I'm only going to use the member initialization list, member initializer list, however it's said. I'm going to use that because I'm not going to do any complex code in my constructor. I just want the class to be constructed. Any failure, I want it to happen after the class is constructed so that it can be correctly deconstructed or cleaned up, the deconstructor run. So here's my initializer list. So we have the render called new render that we passed in. And it's going to complain because I haven't created these yet. Oops, let's just create these so it doesn't. Let's render first. Texture. This one is just called rect. Then we have the bool is white. And the twister engine. Sorry, it's a reference. That's fine. That's fine. It's just because I'm missing things here and there. Okay, so back to the initializer list. We have the image. We have the rect, which we're just passing everything in. Sorry, it's new rect. And the is white. And lastly, we have the gen. Okay, so forgot the MT right there. And it looks like it's happy with that now. So every member variable is actually something that's being passed in currently. And I don't have any other things. We are going to have some public methods. We're going to have a reset. This reset is going to be in the beginning of the game. It's just basically randomly setting the flake. Or if the flake touches the ground or the player, it needs to be reset again. So we have a reset. We have an update method, which will just move the flake. And we have a draw method, which will tell the flake to draw. So these are all going to be public. And I have an is full. It's actually not in this video, so I'm just going to leave that for another video. So update. What I'm saying is I have a parameter that I'm putting in here, but I'm not actually using it right now. So I'm just going to hold off on creating that because it's not relevant to this video. And the draw. This one I'm going to do the const because nothing needs to change about the flake in the draw. And memory is already in main. Okay, so that is basically our class. So now if we include this into game, it shouldn't complain anymore. This is not spelled right. It got the flage. That's not right either. Okay, so it's happy. That's good. So let's look at implementing what we need to implement for the flake. We're going to be dealing with the uniform distribution, and then we have the draw. The draw method is really straightforward. If we just do it the way that we've done it every other time, we're not flipping it or anything, so it's going to be simple. So void, I'm just going to do draw first. So this one is going to be the SDL render copy, and we need a render, which we have. Then we need an image. Then we need the rectangle. So we do have a rectangle. We're using the entire source, so we're going to use null pointer for the source, but the destination, we have a rectangle, so we're going to do that. And we're passing in a reference to the rectangle, or the address of the rectangle, sorry. So we need to do that here. So I didn't do this right. This is a function instead of a class method. There we go. Okay, so that's the draw. So every flake will be able to draw itself now. And now we're going to look at the reset. So this will be changed in another video where I have two different resets. I have a reset where it's like a full reset and a partial reset. That's the bit of the code I'm skipping in this video. There was a Boolean I was going to pass in. It's not important right now, so I'm going to skip that. We'll talk about it in the next video. But the uniform int distribution, this is the, we want a random number, but what's the range of this number? So we're going to create that. And then when we have that, we're passing in our random number generator into that. So I just want to look real quick because I was confused about this one right here. Let's just look around. Produces random int. What I want to know, is this inclusive? It looks like it's inclusive because we have a 1 to 6 here, and the possible output is 1. I see 1s and 6s. So it's inclusive to both ends, it looks like, even though it doesn't specifically say it here. I wish it would say that, but it looks like it's inclusive because this is 1, 6, and it's not like 1 to 5. There is 6 in the outputs too. So by the output, we can determine that it is inclusive. So what I'm going to do is I'm going to say std uniform int distribution, and I want it to be an int. The reason why I want it to be an int, because this is a number that's going to be put into the rectangle for the x position and the y position, and the rectangle in SDL is 4 ints. So the type I want is an int. And this one is going to be for my x position. So I'm just going to call it rand x. That's what I'm naming this thing. Now, let's think for a second what we want this range to be. If this is my screen from here to here, my x, if I have a flake drawn on my screen, the x is the left side of the flake. Now, I want these flakes to always be on the screen. You can change this if you want something different, but the way I'm setting it up, I want my flake to always be on the screen. That means if my x hits 0, my flake is on the screen. That's fine. If my x hits the width of the screen, my flake is actually completely drawn off the screen and I can't see it. So my range I want is going to go from 0 to width of the screen minus width of the flake. So that's the range that I'm going for here. So I always want my flake to be randomly generated somewhere in that range. So I'm going to use 0, and then I'm going to say window. So we have window width minus, and this is going to be the rect, this rect.w. So this is going to give me this, this object called randx. I can use it by passing in the Mersenne twister engine, and it's going to give me some random number between 0 and the width of the screen minus the width of the flake. So let's make another one for the y position. And this one's also an int. I call it rand y. Maybe I'll use it, make it more readable. Yeah. This one's going to be a bit weird. I guess in this video, it's going to be on the screen. So, but it will change in another video. So in this video, since I want all the flakes to be on the screen, just for demonstration purposes, 0, the y0 is going to be on the top of the screen, the height of the screen, and then minus the height of the flake. So we're going to do the exact same thing. Although In the next video, we're going to change this because we actually don't want them to be on the screen. We want them to be above the screen, and it's going to get a little bit more complicated. But for just showing flakes randomly on the screen right now, we're going to do the exact same thing as we did with the X, but with the height. So window height minus this rec, whoops, that's not right. Rec.h. Okay. And now we want to actually use these. So I'm going to say this rec.x is going to be equal to rand x. And I wonder if I should have used camel case here. It is C++. Sure, why not? Okay, so we have rand x, and we have our Mersenne twister engine already set up. It's this gen right there. And that is going to this uniform distribution with the Mersenne twister engine is going to give us a random x number. So we'll do the same thing for y. And that is our reset. So that's everything that we kind of need right now for the flake. Main is implicitly brought in by flake. Random is implicitly brought in by main. So they don't need to be there. Okay, what is in here? I'm going to close these. These are done. We don't need player. Don't need player. Don't need main. So we do have our flake. We have a vector of flakes, a vector of unique. Okay, so that's what we're doing there. So let's go into game itself. Now we have to think about, we're going to create a bunch of flakes now. So what I'm going to do is I'm going to make a for loop. I'm going to make a unique pointer to a flake. I'm going to reset that flake while I have it. And then that reset will randomly set the X and the Y position of it. And then I want to move that unique pointer into the vector. I guess before we do this, I skipped a step. It's going to be pretty easy though, because we've already done this before, is I actually need to load the white and yellow flakes in load media. I need to populate the width and the height of the rectangle. So we've already done this before, so this is going to be pretty quick, but in load media, we've already loaded a background image before. So it's going to be the same. This image is going to be called white image. That's what we've already called it. So this already exists. And it's just called white is the name of the PNG file. White image, loading texture. That all looks good. And we need another one of these. And this one's yellow. Right here it's yellow. And we've already created these. If you don't know, I'll just show you again real quick. These are created right here. So these pointers already exist. But we've already created these white and yellow recs too. So I'm just kind of filling them in now. Okay, so this is on the reset. I believe I need my deleter here because these are shared. So you don't set the deleter when you're declaring the shared pointer, but you do need to when you populate it. So this is destroy texture. We've already seen this before, so I'm not really going to explain it. So this one's not complaining, but it should be. I guess that the LSP is not smart enough. I don't know. Or it's just going to say you don't have a custom deleter. That's fine. But we do need to have one. So we have the yellow right here. We need to make sure that we're checking the yellow. So we have a yellow image. We are loading the yellow PNG, and we are checking to make sure that pointer is in fact populated. Okay, so this is loading our images, but we want rectangles too. And we already know how to do this because we've done this in the player. So if we just look in player, right here, the query texture, we're going to do this. So I'm just going to yank this, go back into load media under the white image. Again, we could have done this just one time because the white image and the yellow image are actually the exact same size. But by doing it twice, you can actually load a different size image and it give you a little bit more flexibility. So the image that we are querying is called white image. And the rectangle that we're sending in is white rectangle or white rect. Okay, white rect. And I think that is fine. White image, white rect, white rect. So I'm going to do the same thing for the yellow image. Okay, so that is us loading the images and populating a width and a height for the recs. And I just put one in. What I'm going to do is I'm just holding one rect for white, one rect for yellow, and I'm just going to pass them in to the constructor of the flake each time they're made, if it's a white flake or a yellow flake. And inside the flake, when it does the reset, it has its own copy now of the rect, and it will change the X and the Y values, but the width and the height will always be the same. Okay, so we should be done there. We shouldn't need this anymore, and we shouldn't need this. Okay, so now we are back here again. So we set up the player here in our init. Now we're going to set up, say, 10 white flakes. So I'm just going to use a for loop. I equals 0. Just a plain Jane for loop, nothing special happening here. I try to make it fancy, actually, using more kind of advanced C++, and it ended up just not. It ended up being more complicated, and the plain for loop just does the job. So what I'm going to do is I'm just going to make the unique flake, and then I'm going to tell that unique flake to reset itself, and then I'm going to move it into the vector. So I don't want to write all that whole unique flake thing out again because we know it's a unique flake. So I'm just going to use auto. And I don't really like to use auto. However, I also don't like the extremely verbose type that I would need to type in for the type of this flake. So I'm just going to use auto. So I'm going to use make unique. And it's going to be a flake. So we're passing in all the stuff that we need to pass in. We need to pass in the render. Since I'm making 10 of these are the white flakes. Okay, so since these are the white flakes, I'm going to pass in the white image. And I'm going to pass in the white rect. Now, remember, when I'm passing this in, this is a shared pointer. This is a shared pointer. This is actually just the value of this rect. So I'm not passing in a reference to the rect or a pointer or the address of the rect, anything like that. I'm literally just copying the rect. The rect is 4 ints. So it's just making a copy of the rect, and that copy will be held inside the flakes. Nothing fancy, because I don't want it to change the original one for sure. I want it to have its own copy. I just want the values of the width and the height to be in there. And we need to know if this is white or not. And this is a white flake. So I'm going to put true here because there was a Boolean on that one. And the very last one is the Mersenne twister engine. What's gen? Okay, that should be the entire thing right there. Flake reset. This is going to give it a random X and Y value. And then we want to move this into the vector. So I'm going to use this flakes dot, that's the name of our vector, remember, is flakes. Flakes dot and place back. Now I need to move it because this is a unique pointer. So I can't just tell it to be there. I need to move it. So I'm moving it into there. So now this was just kind of a local for inside of this loop. Now it's in here permanently in the flakes vector. Okay, so this is making 10 white flakes. Let's just see if this does something. We do need to make it, tell it to draw itself. So under the player, so I'm going to just, for each flake in the flakes vector, I'm going to tell that flake to draw itself. So I'm going to say auto flake. So this is going to go through the vector and get a flake out at a time. And we're going to say flake draw. And that should draw all the flakes. So I do have this vector. Before I even try this, I want to deal with cleaning the vector up. So the way we can tell the vector, it's a vector of unique flakes, but the way we can tell the vector to clean itself up is to just clear the vector. So I'm going to say this flakes dot clear. So this should empty out the vector, and also meaning each one of those unique pointers is going to clean itself up. Okay, so if we do this, we should get some white flakes on the screen, unless I've made some horrible mistake. We'll find out. This was video 10, the final one. So what I'm going to do is I'm going to tell it to rebuild. So it's rebuilding what's in the source directory, what we're working on. Okay, this is great because I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10. If I do it, I'm going to take off this rebuild so it just runs it. And they're in a different spot. And they're in a different spot again. Perfect. So basically, we don't need to do much for the yellow because I'm going to keep the yellow and white flakes in the same vector. So I'm just going to copy this. And I'm just going to say yellow flakes. And I just need to make sure that the image is the yellow image. And now there's a Boolean, also the rect is the yellow rect. And this Boolean is for is white, if the flake knows that it's a white flake or not. So this one will be false. And that should be the same. And right here where we have 10, I'm going to set this to 5. So we have 5 yellow and 10 white flakes. You can adjust this to whatever you like, but all the rest should be the same. Cleaning up is the same. Drawing the flakes is the same. So I'm just going to run the same command again. And now we have 1, 2, 3, 4, 5 yellow flakes. See if they're in a different spot. Perfect. I know we kind of didn't see it till the end because there were so many moving parts happening there. We did get to see the random number generator working and all this stuff. It's kind of one of those things where you don't get to actually see something happening until you do all the steps. Let me just walk back through what happened here then. So in load media, these are things we've already done before. I'm holding an image in the game class for both yellow and white image, but these are shared pointers this time, not unique pointers. So they're still smart pointers, but they're shared. So we do need to make sure we put the custom deleter in here. So it's not in the background one because this is a unique pointer. Custom deleter is on the declaration. This one, it's on the when it's actually being instance. So here is the custom deleter for both of them. We've already kind of seen loading an image before, so we know this image load texture function that's happening, the render, the image itself. There's our custom deleter. We know how to check it. The same, throwing a runtime error, creating the message. And then we've also seen this before in the player class where we are querying the texture to get the width and the height out of it. And we are passing in, this is the address of, since it's a C function, we're passing in the address of the white rect width and the white rect height to populate those two based on the size of the texture. We're doing the same thing for the yellow. These are things we've seen before. In the Flake, basically all the members we have right now are stuff that we're being passed in. So we have a shared pointer to the render, a shared pointer to the image. We have a rect. We have a Boolean if this specific flake is going to be white or yellow. And then we have a reference to our Mersenne twister engine that is actually being created in the game class. So all these are being passed in with our constructor and our initializer list. And we do have these three public methods here, the draw being const. The update is, we haven't even defined update yet, so I didn't even need to put it there, but it's there. But it's not being defined here yet. So our draw is box standard, what we've been doing the whole time. We have our render, we have our image, we have a null pointer, so it uses the whole source of the image, which would be the image of the flake. And then we have a rectangle so that the flake is displayed correctly on the screen at whatever position we want. So that's our destination rectangle. So we're using this uniform int distribution. It needs to take in a random number generator. So we're giving it what we want it to be. For this video, it is the width, 0 to the width of the screen minus the width of the flake. And then the height is 0 to the height of the screen minus the height of the flake. And we're using it down here with our number generator. And that is giving us an X and a Y random spot. So whenever we call reset, it's going to give us a random spot again, which we are doing when we create the flakes here in game. So let's just see in game, we've added a couple things. We do have down here, we have our shared pointers to our images, our rectangles, our two rectangles. We have a vector that's holding all the flakes. This is going to hold all those unique pointers to the flakes. And then we have our random device, RD. It's only used once. And our Mersenne twister engine called gen. So up here, we are just initializing it to nothing. That just sets it up. And then we are using it right away, the operator method or whatever on this class to generate a random number that we are using as the seed for our Mersenne twister engine. So in the class, to make sure we clean up the flakes, we're just clearing the flakes because they're all unique pointers. So that's all we really need to do right there. Why is player here? Yeah, player should be an H. It is. Huh, that's weird. They didn't even complain about that. The LSP adds includes randomly that I generally don't want, but I don't know how to shut it off yet. So to clear the memory that is, all the flakes are holding their own memory on the heap. They're all unique pointers, so that is being cleared with flakes clear. Here's how we are creating each of the flakes and putting them in the vector. So this is just a for loop. So it happens 10 times. And we are making a unique pointer of a flake. So we're passing in the render, we're passing in the white image, the white rect, true for it being a white image, and the Mersenne twister engine right there. This is creating a unique pointer right here in the local scope. We are calling reset on that, so it gives us a random X and Y using the method on the flake. And then we are taking this unique pointer that is a local variable right now, and we're moving it inside of the vector, which is called flakes. We're just using in place back and stood move to move that unique pointer into the vector. And we're doing the exact same thing for yellow. It's just the exact same thing. Yellow image, yellow rect, and false on the is white. Down here in draw, we're using a for loop. This is just taking a reference to flake out of it's going through the whole vector of flakes and taking reference out for each one of them, and then we can call draw on it. So we're just basically going through all 15 of the flakes and telling each of them to draw themselves. And we have nothing for update happening right now. So that's it. I wish I was more confident explaining the random number generator, but you can read about it. If I've missed something or made it confusing, you can ask a question. I'll try to answer it. But I hope that was entertaining or educational and you had a good time. So have a good day, and I'll see you in the next video. Bye.